Let me read to you the problem. So some evidence from previous literature suggests that blondes have higher pain tolerance compared to brunettes. However, because there is still variation in color hue among blondes and brunettes, then we wanted to know if such more specific variation can also predict variation in their pain tolerance of our participants. So I asked you to run the analysis, and I also asked you to write a short report based on the result of the analysis, which should include the objective of the study, the alternative hypothesis, the exact statistical analysis used, and then the result of the inferential statistics without the descriptive yet, because we have pointed out that the ANOVA result really doesn't tell us which of the means are significantly different. So at this point, it would be useless to talk about the descriptives. And then I wanted you to talk about the effect size, and then the post hoc use, and then the post hoc result. And this time, because the post hoc tells us which of the means are different from which other mean, this is the appropriate time when you should also include the descriptives. And then finally, the non-statistical meaning or the elaboration of your interpreted results. So let's do that. So this is our data set of pain threshold. This is our data set. The first column is not really pertaining to any variable. This is just the case number. So if you can see there, participants. So this means to say that we have 19 participants, and they're just sort of labeling the participants. Participants 1 to 19. And then our next variable is the hair color, as mentioned here in the header of this particular column. And it's a categorical variable. There are 4 categories, and the 4 categories are light blonde, dark blonde, light brunette, and dark brunette. And then finally, we have our dependent variable, which is measured continuously. So this is pain tolerance. And because this is continuous, we have to specify it as a continuous variable. So we click on this little icon here, which right now looks like a Venn diagram. Double click it. Then you can specify what kind of variable is this. Is this nominal or categorical? Is this ordinal or is this continuous? So we're saying it's continuous, so we specify it to be continuous. And then when we're done, we click this arrow here, and we have already reassigned this particular variable as a continuous variable. So these scores are scores for pain threshold. So this suggests that, of course, higher scores means higher pain threshold. And we want to see if the variation in the average pain threshold across light blondes, dark blondes, light brunettes, dark brunettes are significantly different. Of course, to do that, we will run ANOVA. Okay, so let us run our analysis of variance. So to do this, let's click on ANOVA. Now, in here, in the ANOVA module, you have your one-way analysis of variance, and then you have ANOVA. And one problem with this particular option is that it doesn't have an option to display effect size, which is very important. And so we have here the other option. The main difference between these two is that this is only used exclusively for one-way analysis of variance. But this module can be used for one-way ANOVA, or two-way ANOVA, or three-way ANOVA. This is a more flexible option. Likewise, this option can also provide us with our effect size, particularly our eta squared. So between the two, let us choose this module, ANOVA. So these are our options. And then this is the table waiting to be populated by information as soon as we select our options here. Our dependent variable is pain tolerance, so we select pain tolerance and we transfer it over here. You will notice here that it says fixed factors, so factors refer to the independent variable, and it's plural, meaning to say that you can actually put in here more than one independent variable, but we only have one independent variable. So let's just select hair color and transfer it over here. And voila, you already have your output. What can we say about this output? What kind of information does this output provide us? So this is the variance between the pain tolerance across the different groups, while this is the variation in the pain tolerance that we would expect to happen by chance. which essentially is a measure of the variance within each group. And when you divide 453.6 divided by 66.8, then what you get is your F ratio. So this F ratio tells us that the variance between the means greatly exceeds what we expect to happen by chance. Now, the variation we expect to happen by chance is just a variation of 66.8. But what we are seeing here is a blown out variation, 453. And that's why our ratio is very far away from 1. Had they been the same, then our F ratio should have been 1. But we can see that instead of 1, we have here 66.79. And our p-value also tells us that the probability of this ratio to happen by chance is very, very slim, with a p-value of 0.004. The p-value is suggesting that there is significant variation or significant differences in the pain threshold among individuals coming from different groups based on their hair color. However, this information is incomplete, and it's incomplete because while we have 4 means, 4 groups, ANOVA is telling us that there are differences among these 4 groups, but ANOVA does not tell which specifically or where specifically are the difference. Is it between this mean and this mean, this mean and this mean, this or this, this or this, this or this, this or this? There are many possibilities. Now, what should we do next? First, let us take a look at the nature of these differences by looking at our descriptive statistics. So if we go to, okay, let's do this first. Assumptions check. Let's go for homogeneity test. We want to make sure that the variance within each of our 3 groups are the same. So we're looking for the test of homogeneity of variance with a p-value of 0.692. That is not significant. That means to say that there is no significant difference in the variance within each group, and therefore that satisfies our assumption of homogeneity or equality in variance. Now, because the p-value is not significant, that means to say that there is no significant difference in the variance within the groups, and that is exactly what we want. So we have already satisfied that particular assumption. And then let's click on estimated marginal means so as to give us an idea of our descriptives. So itong hair color, let's transfer it here over to the other side. So this is our plots. So the small circles here represent the mean pain threshold for dark blondes, the mean pain threshold for dark brunettes, light blondes, and light brunettes, and the line we're seeing represent the confidence interval around these means. But we also want to see, so from here we can already see that light blondes have higher, at least numerically higher pain threshold. We don't know if it's significantly higher. We can also take out the actual values. So if we click on marginal means table, so there. So the higher average, the higher means, that means a higher average pain threshold. And numerically, we can see that the highest pain threshold value is that of the light blondes, followed by the dark blondes. And then the dark brunettes seem to have the least pain tolerance, and then the light brunettes. So these are the means that we are comparing. So these are the between samples or the between groups means. The only problem I have with this particular output is that instead of the standard deviation, they display the standard error. So, and there are no other options here for the descriptives. So maybe what I can suggest is just as a supplementary analysis, and we can do this later on, we can run what we did a while ago, which is the descriptives that are split by categorical grouping. So we now see the means, but we don't know exactly which one is different. Probably it's kind of obvious that there is no overlap between this confidence interval and this confidence interval. So we're kind of confident that this mean is significantly different from this mean. There is also little overlap, little to none overlap between these two confidence intervals. So we're also kind of confident that this mean is different from this mean. However, this mean, we can see that its confidence interval overlaps significantly with this group. With this group, there is some overlap in their confidence interval, and also with this group, there's also a certain degree of overlap. So let's go to our post hoc. The default here is Tuki, so I guess that will be sufficient. So let's transfer hair color over to this side, and when we do, we have our Tuki post hoc result. What we can look for are these values. So these are the p-values of our Tuki comparison. So you will notice over at this side, so these are the comparisons that have been made. For example, they compared dark blondes with light brunettes. So they compared dark blondes with light brunettes, dark blondes with light brunettes, dark blondes with dark blonde versus light blonde, dark blonde and light brunettes, dark brunettes, right, so forth and so on. So these are the various comparisons. All in all, we have six comparisons, and these are the p-values. So let's take a look at the p-values, and let's identify p-values that are lesser than 0.05, and those are this and this. And what are these comparisons? So not these three, not this. So the significant comparisons are dark brunette and light blonde, and light blonde and light brunette. So in summary, light blondes and brunettes, regardless if they're dark or light brunettes, which is exactly what we already saw in our plots. This is what we already identified a while ago. Light blondes and dark brunettes, light blondes and light brunettes. Now finally, let's take a look at our effect size. So you have the eta squared, and then partial eta squared, and then epsilon squared. So let's use eta squared, and you'll see that output right over here. There you have it. So this is the result of the eta squared. Now the meaning of the eta squared will be more meaningful if we try to convert this into percentage. First of all, when you talk about the effect size in ANOVA, this is unlike Cohen's d, wherein you describe the effect size as small, medium, large. The effect size in analysis of variance is pretty much similar to the effect size in regression, wherein we actually term the effect size as variance explained. So that is how we term this. So variance explained mean to say that, so right now we have a dependent variable and we have an independent variable. Our dependent variable is pain threshold, and pain threshold has a variation, right? Some of us have higher pain threshold, some of us have lower pain threshold. Now the question is, why is that so? Why do we have different pain threshold levels? And the answer to that is a number of factors. It could be genetics. Right now, currently at this moment in time, we might have a variation in pain tolerance because of some of the things that we ate last night or a while ago. It might also have to do with the weather. For example, probably there are days wherein you have higher pain tolerance versus not having higher pain tolerance. I'm of course I'm guessing here, but my point is that there are multiple factors that can influence one's level of pain tolerance. And if we try to account for all of the possible variables, we are accounting for 100% variance. 100% of the variance in pain threshold. Now, this value is suggesting that out of 100%, if we convert this into percentage, 57.6%. So what this eta squared is saying is that, by the way, this is just an estimation. Of course, this is not an exact value. This is saying that 57.6% out of the 100% explanation of why we have different levels of pain threshold is because of the variation in the hair color. Again, we can phrase this as saying that 57.6% of the variance in pain threshold, which is our dependent variable, can be accounted for or can be explained by the variation in hair color. And what is that variation? Being light blonde, light brunette, and dark brunette. So that is how we interpret the effect size. All right, so that's it. So that is how we run one-way analysis of variance in Jamovi. So I hope that you learned something new today. And if you like this video, like and subscribe.